Boom! This is one take. I don't know what I'm doing. Okay, so I essentially am aspiring to learn more about blockchain because, what am I looking here? I want to learn more about blockchain because I'm really interested in this space. I think there's a lot of validity in it, but also I was a marketing major, so my credibility standpoint held completely to zero. But I'm here to learn and I'm here to educate myself and essentially, pique your guys' curiosity of, whether you want to do your own research or what you're learning. I'm here to share my learnings. So I did what every single human does in this day and age is go on ChatGPT and go, what the fuck is blockchain? The ChatGPT said some long ass explanation I didn't get understand. So I was like, hey, break it down for me. So essentially, I'm tasked now to learn blockchain basics. So there's a resource actually. It's the title is Blockchain Basics: A Non-Technical Introduction in 25 Steps, and it's by Daniel Drescher. Seemed like an interesting read. It seemed like it was great for beginners and doesn't require a technical background. Also, like I said, I'm a marketing major. I did Cocomelon for 4 years, so take that what you will. So essentially, the bit of the intro, I can describe what was there. Technical foundations of blockchain, essentially what the book will go under, and I highly recommend reading it because I've only gone through 30, 40 pages. Very interesting so far. Very easy to grasp, and also I'm an idiot, so that should be saying something. There's credibility right there. Fundamentals of software engineering, again, marketing major, no relation to that. Required terminology is going to be included here. Why blockchain is going to be needed. Individual concepts, interactions. My notes are here, by the way. I'm not just looking at blank space or whatever. So I'm going to be looking down here a lot because, this is just fresh on top of mind. Application of blockchains in areas of active development and research. That was kind of the main topics that the book will be covering. So yeah, I guess I'll start in the beginning off with stage one. Thinking in layers and aspects. Software systems, according to the book, was saying it's a composition of layers. And we kind of have to think about how we partition and layer individual things. So let's take a cell phone, for example, right? You're calling motherfuckers and you're like, oh yeah, the phone works. I can hear the other voice, but you're not realizing the individual parts of that cell phone, right? There's the radio waves, there's the microchip, there's individual technologies there that we don't essentially see at face value. So it kind of again fundamentally goes down to what layers are. And so there are four different subsectors, but two relate to other, kind of creating a T-chart, application versus implementation and functional versus non-functional aspects. Now, the application part of the layer is essentially what to do with the user's needs. So it's, listening to music, taking photos, taking that rad-ass sunset. I can't believe I just said rad. That was really lame. Implementation, making things happen. So, converting that digital information into an acoustic signal. Sounds complicated. We don't really think about it when we're, listening to music. I'm usually bumping a Lil Uzi or a Playboi Carti, and, I'm not really thinking about the sound waves like that. So it's technical, but essentially it's a means to an end. And then when we look at functional versus non-functional, functional essentially is what it does. Non-functional is how it does it. And one of the biggest key points that the book really emphasized was integrity. And integrity essentially means it behaves as it was intended to. And security and correctness are a huge integral part. Integrity, get it? Security and correctness are a huge part of integrity. So flip the page. Integrity is essentially the non-functional aspect of the system. We have data integrity, right? There are three things here. Data integrity, behavioral integrity, security. Jesus, bro. Okay, my bad. Sorry, this is weird. Data integrity. Data used and maintained are complete, correct, and free of any contradicting kind of information. Take that as you will. Behavioral integrity. Behaves as intended and free of logical errors. Of course, you don't want your shit fucked up. You don't want your shit messing up and a little glitch in the system. Now you don't want none of that. Security, able to restrict access to data and functionality to authorized users only. You take some flicks on your phone. You don't want no one looking at your shit. None of that shit. Or you got bank account passwords. I don't want nobody else doing my money, so restrict access to that data, you know what I'm saying? Then usually you take that for granted. You kind of believe that when you are using an application that integrity is already in depth and implemented within there. And on occasions it can fail. And so luckily mass producing of a B2C market, right? We typically only use products that have great integrity, and there are occasions where it could fail, and that kind of looks like, loss of data, illogical software behavior, strangers able to access your data like hacks, data leaks. It's a very highly valuable commodity, but in the everyday setting, the everyday consuming setting, we don't really think about that. Excuse me. A seemingly tiny aspect of it is you spend lots of time on it. You don't spend lots of time on it. Software engineers do. And I guess as a consumer, you don't really think about it, like I said. But as a software engineer, I'm not one, so I can really attest to it. But I'm sure there are software engineers who might be watching this and be like, yeah, I spent hella time on this. Like, my boss is on my ass and the integrity of this shit. I'm going to fucking lose my job if I don't fix this shit. You know what I'm saying? So then we go on to the software architecture in relation to blockchain. Modularization is a term that they used. Essentially means customization, or the ability to create different modules and different parts to create a unique sort of system. There are aspects of layers to, like, an example, a payment system, right? There's... Let me scroll up, actually. Sorry, this is completely unprofessional, but I just don't care. So I'm going to scroll up because I'm also learning here too. So a payment system, right? There's the functional aspect. So on the book, right? And I can't really describe it right here. There's like this T chart, right? So it's, right? So you have like functional aspects, non-functional aspects, and then you have another line right here where it's application and implementation, right? So the functional application right here is doing like the Naruto type shit. Functional, it's like deposit money, withdraw money, transfer money, monitor account balance. Essentially, it's the functional aspects that we think of the application that we are cognizant of and that we're looking to get out of. The non-functional aspects of the graphical user interface, might look good. It's easy to use. You can transfer money done very fastly. The system has many people you can use, so you can sell people money. And then the non-functional aspects of implementation is, it's available 24 hours a day, right? You don't really think about the availability of it. It's fraud resistant. It maintains its integrity and ensures user privacy. And so there's actually a question mark for the functional aspects in the implementation setting. And that is completely dependent on which system you choose, right? You can use Chase, Wells Fargo, Fidelity, any financial app. They're going to be a little bit different, right? And the functional aspects of how it's worked in the implementation setting, how it works, the way it works is completely dependent on the back end the software engineers use, and we wouldn't know that as a consumer. So there's two types of software architectures according to the book: centralized and distributed. I don't know why it was so hard to say. Centralized, it's located around one central component, like a giant node, and there's like little pieces coming out of it, like a kind of like a spider web. And there's a not like a spider web actually. It's like a spike ball thing. I don't know what the fuck I'm saying. Little spike ball thing. And then there's a distributed sort of system where it's a network of distributed network is essentially a network of connected components without any central element. So that one's more like a spider web where it's all interconnected and everyone's like poop up up, you know what I'm saying? There's an element of coordination and control. So then it highlights down in the book. I don't know why I'm speaking so fast. I need to chill out. Jeez. Okay. I didn't even drink coffee this morning. I don't know what the fuck's happening. So advantages of distribution systems, right? There is higher computing power, higher reliability, cost reduction, and ability to grow naturally. So the individual reset. What I was talking about with higher computing power, right? It's the result of combining computing power of all the connected computers. So the best way I can understand it, and correct me if I'm wrong, would love to hear in the comments or anyone messaging me or anything of that sort, any sort of feedback of if I'm totally off base here, because again, I'm learning here. And I'm just here to share my learnings. If you have 5 bananas, right, you'll be more full than if you had 1 banana. And the combination of 5 bananas will feed up your stomach a lot more than that 1 banana. Don't know why I use banana as an analogy, but that's the best way I can put it. Essentially, it all combines and congregates together to build a one bigger sort of central force. Cost reduction, since the price of mainstream computers have gone down significantly, it's a lot more accessible to the average day consumer. You know, the initial cost of a distributed network is a lot higher. However, when it comes to creating these sort of supercomputers that really hold over the network and be able to uh, have users on it, it takes a lot more to create, maintain, and operate these kind of supercomputers than a distributed network, according to the book. It's a lot more reliable because, suppose your supercomputer, we'll put like Karen from SpongeBob, right? Karen from SpongeBob, the big supercomputer. Imagine she went down, right? The chum bucket, I don't know what it was. Like the chum bucket would shut down because she was like the brain operator of that place, even though they had no customers. Anyways, so a whole network can essentially operate even if one computer crashes. And that's the beauty of it, is the fact that we aren't reliant on one singular system to almost continue moving on with life. So there's no single point of failure. And with a single computer, it's a much lower reliability rate for the average consumer. Now, another big benefit is the ability to grow naturally, right? Like I had mentioned with the bananas, right? Like imagine you had 7 bananas. Damn, you're full. That's a lot of bananas to have. So the ability to grow naturally is aggregated based on computing power. So you can increase incrementally on a fine-grained scale, because when you have more computers, that means you're sharing the processing power with everyone else, which essentially pulls in money, right? Like, especially with Eastern countries, like I'm Indian, and there's a whole concept where the whole family pulls in their financial pool, and they all work together and live together. All work and live together, and essentially, the amount of resources they have is a lot higher because they're not living in an individualistic setting. So now we're going to go to the disadvantages, right? Because there are, of course, going to be disadvantages with any technology, and it takes an anomaly to have some sort of system or some sort of technology that isn't going to have some sort of downfall. So one of the first disadvantages is coordination overhead, right? Essentially, since there's no central entity that kind of coordinates the members of these networks, it has to be done by the members themselves, right? So now you're relying on an entire community to self-police itself. And that takes a lot of challenges, right? It costs effort, computing power, and you can't use that on genuine computing tasks because you're spending time, kind of curating the network, making sure there's policing happening, making sure there's a policy guideline happening. And so that's kind of what I'm alluding to here with communication overhead. Essentially, there has to be an existence of protocol of sending, receiving, and processing of messages. It costs effort, and effort that can't be spent on genuine computing tasks, right? So the main mission for any network is essentially to get shit done. You want to get shit done. And when you're having to use your own time and energy, which is the biggest currency we have to mankind, time and energy, it will cost us effort, and that effort cannot be translated. You can't buy back that time. You can't buy back that energy. The dependency on networks, it requires a medium for communication, right? And so transferring information between entities is extremely crucial. Networks have their own challenges, of course. You need it, otherwise there'd be no distribution system, there'd be no communication, no coordination amongst any of the nodes. And just a refresher, what a node is, essentially is a computer, but I think referring it as a node would be not beneficial. Referring it to as a node will make it a lot easier to understand and grasp the whole concept of a system in place versus an individualistic computer. Think of a node just as one singular part of an entire system or / network, like a distributed system network. And so, when you have no network, you create dependency. Now, another problem you'll face with distributed networks is there's a higher program complexity, right? So according to the book, right, Daniel, I forgot his name, Kresher, it's solving computation problems involves writing programs and software. And I'll repeat again, I was a marketing major. I don't know anything about writing code. I don't know anything about technology. So, when it comes to actually developing these kind of networks, it takes a lot of intelligence and manpower and really information to really build a powerful and strong network. So software and distributed networks has their own additional issues of dealing with. Okay, let me repeat that. So software and distributed networks versus centralized networks has its own additional issues because it comes with its own additional sets of benefits and challenges of having to deal with coordination, communication, and utilizing the networks, which all, and at the end of the day, just increases the complexity of the actual system itself because you're not having one central overhead police the entire thing. And now one comes to the biggest and one of the most crucial issues that have to deal with integrity, right? What I had mentioned, integrity was everything for these kind of systems. Integrity is everything for life, right? So security issues. Security. Communication means sending and sharing data that is crucial for computing tasks, right? Because you have to send and receive information for the network to work. Now, sometimes it might be crucial / sensitive information, and no network is going to be perfect. So that'll imply that there'll be untrustworthy entities. Essentially, there'll be some, foo-foo ass, weird people who will try to steal your shit or try to move your shit or try to essentially mess up your shit, misusing in order to access and exploit information, right? Like, you want my Chick-fil-A password? Like, dog, I have so many points in there, let's relax. And then, so less restricted access to a network over nodes. Let me repeat that. So the lesser restricted access there is to a network over the nodes that are trying to communicate, the higher security concerns there will be, because there is less, of course, restrictions will mean more untrustworthy entities trying to steal your Chick-fil-A password. So then we go towards another part of the book, distributed peer-to-peer systems. Peer-to-peer systems are essentially a kind of distributed system. However, they're a little bit different. They're consistent of nodes and, again, individual computers making computer resources, and computer resources, an idea that it's sharing. What they are sharing is processing power, storage capacity, data, or network bandwidth. It's available to all other members of the network with no central point. And so essentially what ends up happening in this network is we're all just suppliers and consumers of these resources. So when we look at applications of these peer-to-peer systems, it's file sharing, content distribution, privacy protection. The more users there are, the more computers that turn into nodes, the larger, more powerful it can become. And so now we get into nitty-gritty and a mixed format of it. And this is where it's going to taper off the discussion today. Because I just haven't read that part to the book. So, I'll continue on once I can. Mixing centralized and distributed systems, which is a very interesting concept, right? So there's a term used there called architectural antipodes. Sounds really weird. And then there's another one called technical antipodes, which essentially is a hybrid system that inherits the strength of a parent. Now, I didn't fully understand this, so if anyone can clarify that for me, that'd be great. Or maybe I'll clarify that in the next video I make. But there are two types of combinations you can make. There's one where there's a central component within a distributed system. So it looks like a distributed system with all these different nodes connecting with one another. However, there's one central node that they're all definitely connected to. Now, when it comes down to the other one, it's a central component that essentially contains distributed a giant circle, right, with a distributed system with holding reside in it. However, outside of the giant distributed central node, there is individualistic nodes attached out to it, essentially acting as a faux centralized system. Now, this is a very interesting concept that I just didn't get further into, which I would love to delve into deeper. But yeah, my name is Tan May. I'm here just to educate myself. I'll also pique interest and hopefully educate you guys a little bit based on my learnings. What was the book again? It's called Blockchain Basics, a non-technical introduction in 25 steps by Daniel Drescher. I highly suggest this book because there are images in this book that honestly help me internalize and understand what the concepts are. And yeah, I would love to hear comments. I would love to have a discussion with anyone who's willing to have a discussion. But yeah, my name is Tan May, and I'll talk to you later. Bye-bye.